When a current flows through a wire, a magnetic field is produced around that wire. The shape of the magnetic field is circular, and you can work out the direction of the magnetic field using your right hand. All you've got to do is make a thumbs up and line your thumb up with the direction of the current. The magnetic field will then be in the direction that your fingers are pointing. So, for example, in this wire, the current is going that way, so the magnetic field will be going that way, like this. And in this wire, the current is going that way, so the current is going that way, so the magnetic field will be going around it like that. The strength of the magnetic field depends on the current through the wire and the distance that you are from the wire. It gets weaker and weaker the further away you get from the wire, and it gets weaker and weaker the less current you use. If there's no current at all, you get no magnetic field. Now, if we put two bits of wire next to each other and the current is going in the same direction, the magnetic fields sort of combine and you get an even stronger magnetic field. And we can use this idea to set up a very strong magnetic field using a single wire. By winding a piece of wire around and around and around into a coil shape, the current will be going in the same direction in each piece of wire. All the pieces of wire lying next to each other will have a current going in the same direction. If you try and picture it in your head, here's a little illustration of how that works. So we end up with lots of bits of wire next to each other with current going in the same direction. So that is going to end up with a very strong magnetic field that looks a bit like this. And you might notice that that looks like the same shaped magnetic field as we had for a permanent bar magnet. This setup is called a solenoid. We can increase the strength of this magnetic field even further in 4 different ways. Firstly, we could increase the current again. Secondly, we could increase the number of coils in the solenoid. Thirdly, we could put the coils closer together. And finally, we could put an iron core through the middle of the coil. That will make it even stronger. And when the iron core is in place, we can call this an electromagnet. And remember, because the magnetic field comes from the current, we can switch this magnetic field on and off by just switching the circuit on and off. It's very, very useful. Like in scrapyards, for example, they use electromagnets, massive electromagnets, to pick up really heavy bits of iron. They switch the circuit on, generates this really strong magnetic field. They can lift up the iron, move it to where they want, and then they switch the electromagnet off, and suddenly the magnetic field disappears and the iron will fall. Electromagnets are really useful in lots of different devices, so make sure you've got a good grip on the basics.